because it's not slope. All right. Y'all brought to my attention, we did not do example number 3. Is this correct? All right. Example number 3 is an example of where we are not actually going to have a numerical answer. You just checking that you're able to set up to find an answer. Okay. The reason why we will not have a numerical answer is because there's not enough information to give us a numerical answer. All right. So I'm going to do a little popcorn reading. I will start the first sentence. Someone please pop in and take over. After surgery, you are given a pain reliever. The level of the medication will decrease slowly over time. Concentration. Pop. Oh no.
Write an expression for the rate of change of the medicine's concentration over a period of time from T equals 50 minutes to T equals 90.
Awesome. So we're giving our time. So we're giving our X values. Does that make sense? So in this case, time is our independent variable. Okay. So we know that our time is from 15 to bracket. That's our X. Agreed? It wants us to find the rate of change. Your rate of change is, in terms of a problem, it's going to be your change in your dependent over the change in your independent, correct? For this problem, we can't calculate our actual value of our Y. So our Y's are going to equal, it's the C of T is going to represent our Y's, right? Does that make sense? So our output is C of T, the concentration that's left in their body. And our X's are represent our T. So when we're trying to find our change in our Y's over our change in our X's, all we can do is plug in what we know. Well, we have if T is 90 and if T is 15, correct? So we have C of 90. I don't know why I can't write. Minus, because we need the change. Change means I'm subtracting. C of 15 over 90 minus 15. Until I know what C of T equals, can I go any further? No. I can simplify. I can clean it up a little bit with simplifying the denominator, which is going to be 75. But besides that, this is the furthest I can go until I know what C of T equals, whatever that formula is for concentration. So I'm preparing to solve, but in this situation, I just wanted to make sure I can set up to solve. Does that make sense? Okay. All right. So this is useful leading into example 4. On example 4, you're going to prepare to solve. You're going to figure out what is my formula for finding rate of change in the situation. Okay. So a car travels over a 2-hour period shown at the right. Is that realistic? As you travel, your distance is going further, right? Time goes, distance goes. Okay. However, when you're driving, are you always driving the same speed the entire time? No, your speed is fluctuating. So as you can see, this graph has a fluctuating speed limit, right? So what it's asking is, what is the average rate of change for the car's travel? So from when I start to when I end, what is my average rate of change? Okay, so we're going to set up and analyze that part. So in this case, our Y's are represented as D of T because it's distance. And clearly our X's are T. So if I'm asking for the average rate of change of my whole travel, I'm measuring from 0 to 120. Make sense? So when I set up to find the average rate of change, so to find my AROC, it's going to be D of my ending. And where do I end? At 120 minus D of where I began. And where did I begin? At 0. So that's your 120 minus 0. In this case, I set up, but can I actually now plug in values? I can. I can actually tell you what D of 120 is and what D of 0 is. Thank you. D of 120 is 100. 100 miles. D of 0 is? And 120 minus 0 is? Is it at 120? Yeah, right? Okay, so then I keep simplifying. And we have 100 over 120. I can drop these zeros, right? And now I'm left with 10 over 12. And we get 5 over 6. And this is, again, now you put in your units. What does your numerator represent? And that's measured in miles. What does your denominator represent? The time, and that's measured in minutes. So this is my miles per minute. So I'm driving 5/6 of a mile every minute. Not a full mile, 5/6 of a mile. I don't have time for y'all's nonsense and your hateration. All right, just make sure we're comfortable. Can you quickly stop? Can you please quickly do B? I'm gonna give you 2 minutes. One, you're gonna have to convert. That's your hint. You will need to convert. Okay, so the first thing you had to do is set up to find your change. So for here, we have D of 60 minus D of 30 all over 60 minus 30. Yes? That's our AROC setup. What was D of 60? D of 60
40.
is 40. D of 30? D of 30 is 20. And 60 minus 30 is 30. We keep mathing. We get 40 minus 20. 20 over 30. And I can drop my zeros. And we get 2/3. So this is 2/3 minutes, miles per minute. But it wants us to be in miles per hour. So if I need to convert, we're going to multiply by 60 because there's 60 minutes in 1 hour. And we get, what's my speed? We get 120 over 30, which equals 40 miles per hour is how fast they were driving from 30 to 60.
Wait, why is 36?
I didn't mean to write 30. You saw nothing. That's up to you.
That is just the 40 minus.
I said you can convert in the beginning or you can convert in the end. Yeah. So instead of working with 30 minutes, you would have had 0.5 hour, 1 hour. All right. Okay. How do we feel? All right. Now, this is where we start talking about our change of rate, aka our slope at given intervals, right? So it asks, when is the car traveling the fastest? How do I know that the car is traveling the fastest?
Look at the graph.
Graphically, how do I know that it's driving the fastest? It's the what? It's the steepest. We're looking for the steepest slope. So our fastest speed is from 70 to 90 because that's our steepest slope. Do we see that? We all agree? All right, calculate it. How fast were they driving?
They were speeding. They need to go to.
How fast were they driving? How fast? 90. Yeah. So you ended up with the AROC for that interval, because we said it's from 70 to 90, right? So our AROC equaled 80 minus 50 over 90 minus 70, which gave us 30 over 20, which equals 3/2. But this is currently miles per minute. When they're radar checking you, are they telling you your miles per minute? No, they're telling your miles per hour. So we have to take this value and multiply by 60. Because I asked you how fast they were driving. You're going to tell me that? But is that what the cop is going to tell you? No. So 90 miles per hour.
Hey, they're going to jail.
All right. Do we get it or do we need to keep practicing? We get it? We're good? All right. Then that. Huh? We're not going to do D, we're going to do E. All right. So D is a little different. D specifically asked me, what is the speed of the car at 45 minutes? So that means when I come here, I said we're not going to do, I asked y'all, did we need to keep practicing finding? I said we were good. Did we not? Are we okay? Yes. What is the slope? Your slope is your average rate of travel. Your miles per hour. That's your slope. Slope is just saying what is your change in Y of your change in X represent? Is your miles per hour. Yeah. So for this one, I mean, I will do it if it helps. So you had 100 minus 80, right? Because at 120, you're at 100. At 90, you're at, guys, at 80. And that's the 120 minus 90. That's going to give us 20 over 30. Again, this is in terms of miles per minute. To convert it to hours, we multiply by 60 because there's 60 minutes in a hour. So we convert because we're going from something small, something big, multiply. And that's going to give us 40 miles per hour. When you're driving, your speed is your slope, right? Yep. So your speed is your slope. So your slope is the average rate of travel, aka your speed on that interval. However you want to word it is up to you, but that's what it represents. Yes, Max.
So when doing this kind of thing, you just multiply 2, 3, or 5, 60.
Well, yeah, because remember we talked about converting. So we wrote it out here. We did our conversion. 60 minutes is 1 hour. Then after that, we realized that all we're doing is multiplying by 60. So then we use what we knew and we just continue to multiply by 60. Yes.
Did you say if it's not linear?
It's asking in context of this specific problem from 90 to 120, that is a linear line, right? Correct? All right. So it asks, what is the speed at 45 minutes? So when you're asked this kind of question, that means you're got to locate where 45 minutes is and identify what part of the graph does that fall under. Does that make sense? Yeah. So when we come here to 45, 45 is going to hit where? Which interval? On our 40 to 60. So that's the interval that I'm going to use to figure out what is my speed at 45 minutes. Okay. And then you just do average rate of change from there. Does that make sense? So I know the question was worded a little different than how the others were because it wants to know what was your speed at a certain time. Okay. Not over an interval, but at a specific time. In order to calculate that, you have to figure out what interval does that fall on. Yes. Yep. And that falls on the interval from 40 to 60. So can I now calculate my speed for 45 minutes? Yes. So at 40, I was going 30. Yeah. And at 60, I was going 40. So now I'm going to calculate. So we have 40 minus 30 over 60 minus 40. And that's going to be my average rate of change, which gives me 10 over 20, which is just 1/2. So I'm going to multiply this by, why am I multiplying it by 60? 60 minutes in an hour. So I convert, how fast was I driving at 45 minutes? 30 miles per hour. Got it? Okay. But we see the difference between that question and the other questions that gave me an interval. Okay. I was given my interval, bam. This one, I was giving a value and I had to find the interval. Once I found the interval, was I good to go? All right. Yes.
You can kind of do plot files, plot files.
Mhm. Yes.